Transformers. Transformers use electromagnetic induction to change the size of a voltage for an alternating current. They are important in the transfer of electricity from power stations to homes and are useful in electrical equipment. It is transformers that make the buzzing noise in chargers, laptops, speakers, and mobile devices. Transformers consist of two separate coils, the primary coil and the secondary coil, wrapped around a core, likely iron, which is not a permanent magnet. The national grid. Transformers are a part of the national grid. Power stations produce a voltage of about 25,000 V. Transmission current is electrical current produced due to transmission voltage/potential voltage transmitted from the power station. Step-up transformers increase this voltage to 400,000 V and decrease the current to reduce energy loss through heat. This 400,000 V potential difference travels through a series of transmission lines/power lines before reaching step-down transformers, which reduce the potential difference to around 230 V, which is safe to use in homes, factories, and shops. How transformers work. 1. An alternating voltage, EMF, passes through the primary coil and causes an alternating current to flow in the primary coil. 2. This causes the iron core to produce an alternating magnetic field. The iron core is said to alternately magnetize, then demagnetize, and then remagnetize again. 3. This changing magnetic field is continuously being produced in opposite directions. A direct current could not be used to do this because a direct current flows in only one direction, and so the magnetic field would not change and therefore there would not be a change in magnetic flux. This means an EMF would not be induced. 4. A rapidly changing magnetic flux has now been created. 5. This now passes through to the secondary coil where it induces an alternating voltage of the same frequency as the output voltage. 6. The secondary coil has a different number of turns to the primary coil. This means that the alternating voltage induced is different to the input voltage because the ratio of the number of turns of each coil determines the size of the output voltage. This equation is for an ideal transformer. Vp/versus equals Np/Ns, where Vp equals primary voltage, V, versus equals secondary voltage, V. Np equals number of turns in the primary coil and Ns equals number of turns in the secondary coil. An ideal transformer has an efficiency of 100%, so its input power would equal the output power. However, transformers are not 100% efficient. Eddy currents are looping currents induced by the changing magnetic flux in the core. They create heat due to resistance, which reduces the strength in the field. A laminating core can be used to reduce the effect of eddy currents.